Welcome there, ICS folks. Today's note is on algorithms. And what's an algorithm? Well, an algorithm we find in our daily life all the time. In the simplest form, it's just a step-by-step process to solve a problem or to perform some sort of task. A better definition, going from pretty straightforward to pretty complicated. So tying your shoes. When you first learned to tie your shoes, there was very first you do this, and then you do that, and then you make a loop, and so on. It becomes second nature after a while, but when you first learned it, there was very few, very definite steps to follow. Baking a cake, we often think of a algorithm as a recipe for solving a problem. So when you're baking a cake, you do this, and then you do that, and then you do that, and then you do that. Adding two 4-digit numbers. Now this is closer to computer science, the algorithm for adding two 4-digit numbers, and you might not remember this much, but you start on the right hand side and you go 9 and 2, and that's 11, but you write down the 1 and you carry the 1, and then you add the 1 and the 0 and the 8 together to get 9, and this is the algorithm, right? And we go start from the right and go to the left. 7 and 7 is 4. Put up the 1, and this is pretty second nature to us, but the idea here is when we start trying to get the computer to do something, we'd have to describe this procedure in very step by step. And notice there is like a repetitious nature. When we went 9 and 2 and wrote down 1 and carried the 1, well, then we did the same procedure for the next column, the same procedure for the next column. And so a lot of time algorithms have some sort of looping structure in them. Determine the remainder when one number is divided by another. Well, this is one of the examples we'll have later. Another very mathematical computer science type one. Kind of more interesting is the software that we use. You're spelling correctly. This is a really interesting one, I think. Like a Google Maps or a GPS system. Find the most efficient driving route from one place to another. How does the computer know? Well, it follows an algorithm. You put in your start place and your end place, and the computer follows an algorithm, a finite set of rules, to solve that problem. What makes an algorithm an algorithm? Here's the properties. An algorithm must be finite. An algorithm must always terminate after a fixed number of steps. Some finite number of steps. So it can't go on forever. And this is one thing we'll have to remember about our computer programs. They have to stop. An example is the word processing document that looks for spelling mistakes. If it can't find it, it doesn't keep looking forever. After a certain amount of time or number of words it checks, it stops and says, you must have spelt this incorrectly. Definite. We must know exactly what to do at every step of an algorithm. So there can't be any sort of interpretation that the computer can make. It has to be definite. It's like, this is what you do now. Sometimes it's a decision. If this is the case, then you do that. But it has to be definite. And there might not be an input. Like it might be just start the process. You can think of the shoes. Well, it has an untied shoe as the input, and the output would be the tied shoe. One or more outputs. And sometimes the output is a message to the screen. Sometimes it's just the algorithm terminating correctly. The last one is the steps of an algorithm must be basic enough to be completed easily. So it's not like one of the steps is solve the universe. If I can solve the universe, then whatever. Well, that's not an effective step. It's too hard of a step in an algorithm. So these steps in the algorithm have to be small enough to be able to be executed either by a person or the computer or whatever. For instance, when we're baking a cake, we might say mixed until fluffy. Well, we're not sure exactly what fluffy means. Well, does it have to be fluffy like a cloud? When in that case, we'd probably be mixing for a long time. Effective is a little bit difficult to get your head around depending on who is executing the algorithm. Okay, I'm going to stop there and keep these videos short. I'm going to pick it up in part 2.